Lesson 10.6, Motional EMF and Magnetic Damping. Another way to produce an induced EMF, remember that's the same thing as voltage, is by moving a conducting rod through a constant magnetic field. Each charge in the rod is moving through the magnetic field with a velocity. So that means each charge is experiencing a magnetic force. That force is QVB sine theta. Because remember, on the rod there's protons and electrons. The electrons can move. So if you're moving them through a magnetic field, you have a moving charge and a magnetic field, they get a force. Since the electrons can move, they are forced to one end of the rod, leaving the positive charges at the other end. If there was then a wire connecting the ends of the rod, the electrons would flow through the wire to get back to the positive charges. This is called motional EMF, with that little E symbol stands for EMF. If the rod did not have the wire, the electrons would move until the attractive electrical force is balanced with a magnetic force. So on the left here is the electrical force, electric field, the charge. On this side is the magnetic force. We're going to set everything up perpendicular, therefore sine of 90 is 1 and it can go away. Electric field would be our voltage divided by the length of the rod. Divide by Q, multiply by L, and you get the EMF, or volts, equals V, the speed you're moving the rod, times magnetic field, times the length of the rod, assuming they're all perpendicular to each other. So here's a picture of it. You can see he's moving it towards the right. The positive charges, then if you use the right-hand rule, your fingers are going directly into the page. Your thumb is going to the right, and so your palm would face up towards the top of the screen. So the charges in the rod are going to be forced towards the top, towards that positive side of the rod, and that's why the current's flowing. Now, once the current is flowing, now it is a current carrying wire in a magnetic field. So you can use the right-hand rule on that. Fingers going into the page. This time, because we're talking about the current, your thumb would point up towards the top of the screen, and your palm would face towards the left. And look, there's a force on this current carrying wire towards the left, opposite the direction you're moving. So according to the right-hand rule, the force is opposite the motion of the rod. If there are no force pushing the rod, it would actually stop. So again, let's run through it again. Okay, you have the rod. You're pushing it towards the right. There's an electron in the rod. That electron is being pushed towards the right. So fingers go the direction of the electric field, straight into the screen. Thumb's going to the right, which means your palm is facing up towards the top of the screen. So the charges are pushed that way. In the picture, that's the current. Once the current is flowing, now you have a current carrying wire in a magnetic field. So that has a force on it. So put your fingers in the direction of the magnetic field that's into the screen. Thumb goes the direction of the current, which is up towards the top of the screen. And the force then would be towards the left, which is the opposite direction that you are pushing this rod.